Hello, everyone. I'm Eli Plaskett, Senior Associate Editor with Modern Machine Shop. Welcome to today's presentation, Software Transforming the Supply Chain with Manufacturing Quality. The presentation will be led by HiQA founder and CEO, Sam Golden. Sam has steered HiQA from its inception to its current industry place. His commitment to manufacturing quality is evident in HiQA's comprehensive suite featuring 360 Core, a manufacturing quality management software, and 360 Hub, a supplier quality management software. With over 30 years of international executive experience, he's founded, co-founded, and managed 5 companies spanning CAD/CAM, PLM, CRM, and knowledge management. If you have any questions, type them into the question pane of the webinar interface. We'll do our best to answer all of them at the end of the presentation. We'll also be sending a link to a recording in case you missed something or just want to revisit the topic. Now, with all of the housekeeping out of the way, let's get started. Go ahead and take it away.
All right. Thank you, Eli, and thank you, everybody, joining today to our presentation. I would like to kind of start in a quick background and a glance, as Eli mentioned. Born in CAD/CAM, company called Cimatron, built it up together with other founders, and then continued to a PLM life with a company called Enovia. Today it's called Enovia Smart Team. And then after understanding the challenges in the manufacturing quality industry, we started to build HiQA about 10 years ago in order to provide a comprehensive manufacturing quality solution. In a glance, again, about HiQA, we, as I mentioned, founded in 2015, about 10 years ago. We have more than 1,300 customers, but you can see the distribution, if you will, that 25% of them are OEM, 35% tier one, and 40% are tier two, three, and four. We have worldwide partners. We speak all local languages and local support. And I think most important thing when in this slide is that we serve the entire manufacturing industries of the vertical, if you will, aerospace, defense, automotive, medical, manufacturing, and machinery. The reason being, born in the CAD/CAM, you can make part for any given industry, but when it comes to quality, then regulation will dictate the way you would like to provide your parts with all the documentation. I will take it a little bit further and talk about what agenda. So we are going to talk about the challenges in the manufacturing supply chain. We'll talk about root causes and how software can help. And then you can look into what can be done as a next step. We'll start in a smile. When manufacturing actually started, it started many years ago in the ancient time when this guy tried to build a wheel, but come another smarter guy who started manufacturing for his family or whatever neighborhood. And then from that point, he didn't need to do massive manufacturing or supply chain, but you can see how this stone will develop over time. And over time means that it goes in parallel to the industrial revolution. So when he did it for himself, that's fine. But in the first revolutionary industry, when steam created and trains started to run on railroad, then you started to distribute it away from your village. And in the second industrial revolution, then electricity created and helped us to build what we call assembly line. Then we get into supply chain, and then this quality created, and this guy started to add more people to his shop because we need to go and handle quality. And then come the third one, which is automation and robotics. And we are now in the industry 4.0, of course, handling all IoT and digitization of every step that we are doing. With that said, we know that critical dependency between OEM and manufacturer is super critical. Every OEM receive hundreds, thousands, or sometimes millions of parts to build a single product to the entire line of products that he build. These components are sourced from a network of manufacturers that serve as essential partners in the OEM supply chain. These independences between OEM and manufacturer is more than just transactional relationship. It is critical component to survival, growth, and future prospecting in a highly competitive market. Manufacturers depends on OEM for consistent business, revenue, and innovation opportunities. On the other hand, OEM rely heavily on manufacturer to deliver high quality parts on time, meeting both the specification and regulatory requirement. Any disruption of this partnership is going to cause delay on production and impacting highly the market access and success. Therefore, fostering seamless collaboration and transparent communication between OEM and their manufacturer is critical, highly critical. Of course, the question is not whether it is needed, it is why we couldn't do it until today and what is available today in order to make it happen. So let's take a deeper look on this example. All right. 40% of airplane parts are manufactured. You can see here the OEM, which is Boeing, Airbus, or Embraer. And looking just on tier one, like Rolls-Royce, GE, or Pratt& and Whitney, they are not just tier one supplier, they are also OEM by themselves. So that's create a much higher complexity when we talk about supply chain, because almost everyone between OEM and tier, call it two, is a buyer and supplier. And that's a huge complexity process. But let's take a little bit deeper look into it and see how many parts actually we have in this case, we're talking about the Boeing airplane. So the 737 has only 400,000, but when you go to 747-8, they have 6 million parts. So when we talk about this, when we look about it, it's like the typical number of parts or average parts per airplane is 3 million. Approximately, as we said, 40% is manufactured, which equal to 1.2 million manufactured components for aircraft. On average, about 2,000 airplanes are produced each year. That means that aerospace industry is responsible for a manufacturing of about 2.4 billion parts annually. This is only for new commercial airplane. We can add into it other flying machine or maintenance, overall retrofit, and the list is long. Let's talk about the scale of manufacturing industry. Now that we established the scale when we talk about airplane, it won't surprise you that average car, your car that you are driving, have about 35,000 parts. You can add 20% for hybrid, another 15% for more complex model. To give you some context on the scale of manufacturing in this automotive industry, in 2003, 94 million cars produced. If we assume that about 60% of these parts are manufactured, that roughly 20,000 parts per car. Let's multiply it by 24 million cars, we are getting to a huge number. Now, when we look into this and we see that OEM deliver million product daily, serving all industries, defense, aerospace, medical, automotive, hundreds of thousands of manufacturers are producing million parts daily, billion of parts manufactured annually. And the good news is that this market, the manufacturing market, represents $15 trillion and it's growing dramatically. 3.6% every year. Well, if we look into this, okay, aerospace and automotive are the driver of it. And with this comes many challenges. If we look into those gentlemen, one of them is from Airbus, one of them is from Mercedes. They are talking about supply chain challenges. We'll talk about the global supply chain challenges. With the good news comes many challenges. Some of them are critical. And when we talk about global supply chain complexity, you can see what happened on the right side. And we are talking about the Dreamliners as an example. It's highly complex to manage worldwide network of suppliers with all the logistics and maintaining the quality standard across regions when you have different languages, different culture, different regulation. It's extremely hard. And you can see and you can learn about the complicated outsource here, although the 787 of course is a great machine. But in this case, Boeing decided to outsource 70% of this new aircraft, that it's not just new aircraft as new materials into it. Not just this, the decision was to outsource only model-based definition, not drawing. So we can see here a thin layer of tier one suppliers, and other them, there are thousands of other suppliers that needed to handle a new way to handle new parts, new material, and without drawing. So one is global supply chain complexity. Supplier dependencies is a huge risk. Many of parts used by OEM are highly specialized, requiring a small number of suppliers that have relevant skills. This creates high level of dependencies on a critical supplier. Then many companies, and I will emphasize Airbus mainly, rely on just on time manufacturing. So a single supplier failure can delay the entire production line, leading to a costly setback. And then we talk about quality control compliance. With frequent regulation changes, update, OEM and essentially supply chain are struggling to comply and spending a lot of time filling up mountains of documents. And then we're talking about production ramp up. This is critical issue. Aerospace OEM seeks to increase production rates to meet growing demand and face challenges in scaling up their supply chain. Many suppliers struggle to increase production requirement, leading to delay or compromising in quality. And I would like to touch on it a little bit deeper. You probably remember years ago what happened to the airbag. 23 deaths, $24 billion lost in poor quality. In this case was Takata, a large airbag tier one supplier. Not just them paid money, also Toyota, also BMW, and many, many others. I didn't put all the list here. But this is poor quality. And as in the previous slide, I mentioned some of those challenges are critical. It's cost not just money, it costs life. On the left side, I don't know if you recognize, but this is the panel that blew out on Alaska Airlines flight this year. And this actually, the outcome Nothing hurt, nobody hurt, but it's very scary. And if we look a little bit into when we talk about these critical challenges, I want to take you to the supplier level without picking up only on Boeing, but that's what we have here. This is a clip that's available to everyone in YouTube. I don't think I'm telling something new, but you can read here the
A
following.
former quality manager who worked at Spirit Aerosystems, a Tier 1 supplier for Boeing, has alleged that the culture at the company has allowed many defects to slip through the cracks, including the one that resulted in the Alaska Airlines mid-flight door plug blowout in January 2024.
So this is scary. As I mentioned, this is available in YouTube. Shouldn't happen, but it may continue to happen unless we will continue to use the same manufacturing quality method, relying on paper rather than on comprehensive digital processes across manufacturer, supplier, and OEM, which consists of database driven between them in collaboration. Another component that creates what I call a layer of disconnect between OEM and supply chain is what they call digital transformation. Large OEM integrates more and more digital tools in their technology. And I mentioned earlier, talking about Industry 4.0, AI, IoT, digital thread, digital twin, a lot of acronym. Once they do it in their operation, they face a lot of challenges. They would like to ensure seamless digital integration across their supplier network. Not all suppliers may have the technological capability or resources to adopt this new system, and this will create a larger gaps in visibility, coordination, and collaboration. Actually, before this Industry 4.0 or whatever digital thread, the gap was smaller. When you cannot comply with digital thread, it's going to be hard. And this is an example here. Let me get here into this example. If you look, for instance, into the manufacturing CAD/CAM industry, this part, and I born there, takes 2 hours from start to create a tool pass and run CNC machine to make the part. But while we are making this part in our manufacturing, someone in quality is still bubbling print by hand. This is not Industry 4.0. And this is highly emphasized the gap between current situation today, between model-based definition that we try to apply, because now the push is to go into model-based definition. Still, the gap is huge. When we are bubbling print and the part is ready, and we are still bubbling print, so we create bottleneck. But not just bottleneck. This is a critical interpretation we which would like to avoid when we talk about Industry 4.0 or a digital thread. Now, many OEMs are trying to move to model-based definition, but it's create a larger gap because getting model-based definition to the supply chain, and don't get me wrong, we will get there. But model-based definition describe the part and quality is a process. Those are two different animals. Quality process requires bill of characteristic. Making parts needs the model and the PMI. And this is another disconnect that the industry needs to close a huge gap and provide supplier ability to handle the model-based definition. There are current solutions trying to do this. IQA, of course, does it. And we can explore more if question will arise about this component on model-based definition. So going back here about another component that is like a myth, that first article inspection is of course a critical step in manufacturing, but we all know that first article alone does not guarantee consistent production, right? And quality, of course. So if you look into it, what is that we are trying to do when we get a part and we provide the first article to our customer, can be OEM or tier one, and then it follows of auditing after the FAI or the first article. Why do we need to have auditing after FAI? Of course, because FAI does not guarantee that the production will be consistent and stable. And then we talked about another gap, and we talk about what will guarantee consistent production quality. And I left it open because when you talk with OEM, they want to reduce incoming inspection. So how in our world we can create a production quality at the supplier side and on the other side reduce incoming inspection? So when you look into it and you said, well, we have to have SPC, statistical process control our production. Absolutely correct. But in our life today, SPC is done at the end of the process. I have a lot inspected, I upload it to my SPC, and I can see if I'm stable and consistent. But this is another disconnect. It's too late sometimes. And when I run SPC either as a supplier or as an OEM, that's not real time. We would like to have real time SPC. So think about creating this CPK, PPK on the downstream, on the quality requirement, on the drawing or on the model. And then when I am making the part, as a supplier, I can see how stable or consistent, but also the OEM can know before you send the parts to him back that your production is stable and consistent. So there are multi activities that we do in the manufacturing process that are completely critical, required, but they are disconnected. All right. So what problem we need to solve in order to get to where we want to go? If we look into any manufacturing facility or OEM, there are many quality systems used by OEM or by supply chain. They guarantee common denominator of massive amount of data in multiple formats or in subfolder, sub-subfolder, and they are all over the place. But actually, this guy can tell you, you have a lot of data all over the place, but you have zero information when you need it. We would like to talk about prevention. Manufacturing quality or any quality either internally at the manufacturer or at the OEM should not be about good parts or bad parts. We are talking about prevention. I don't want to get bad part. The other component, quality requirements are aggressively growing in regulation, update, all those documents, AS9102 Rev C and 1300 and PPAP, CFR, ITAR, CMMC, it's tons of documentation and paper that you need to fill out and comply with. In manufacturing, growing 3.5% a year, which I need to make more parts, I can buy another machine, I can put robot in place, but I cannot get over documents. And this required tons of manpower to fill up documents, because today they are on paper. Excel, very massive Excel, of course. That needs to go away. In a way, it should be together with the part making, integrated with part making. It should be automated. Talking about PPAP, control plan, FMEA, whatever I'm doing on the part level should propagate it into the document level. Let's take another look, and I changed the view of the slides just to give it another way of looking into it. I talked about it. More and more OEMs wants to use 3D model instead of 2D prints. The OEM do not understand, and I'm lecturing many OEM, train many OEM, how to handle model-based definition with supply chain. They think that they're gonna give you MBD, whatever native file, CATIA, step 242, which is a format, or Creo or Siemens. They said, hey, you have PMI, you have the model, you can make the part. Yes, you can make the part with this. We don't need it. We can have step file to make a part. But when it comes to quality, we are talking about two different animals. MBD, as I mentioned earlier, described the part. Quality is a process. Look into the model and said, oh, I need to do in-process inspection. I need to do roughing, semi-finished drilling, whatever it is. How do I do it here? I need to create FAI. How can I create FAI out of it? The gap is huge. The OEM, in a way, say, solve the problem. It's a big gap. Should be solved. We solved it, but we may talk about it a little bit later. And maybe last one, if you look into the measuring machine and tools, every day more and more inspection tool added. They are not added just to having another inspection tool. You have to inspect part, you have to report on it, where it is goes. Anywhere you go, you can find tons of papers, and then somebody take the paper to the quality, and somebody click the data into the quality paper, and then somebody else put it together and send it to other guy to do FAI. It's like, it's endless. It's frustrating, it's tiring, and it required a lot of resources to do it. So going here and asking, how can software help? If we look into how can software work, first of all, eliminate paper, spreadsheet, and what we call the antique file system, silos, paper, draws, folder, subfolder, subfolder. It should be database driven, 100% revision control, because we had a lot of engineering changes. By the way, not just on the part level. We have engineering changes on the document level, PPAP, okay? So you would like to eliminate data re-entry. What does it mean re-entry? I don't want a redundant data in all kinds of papers. I do it once, it should be once. And of course, enable 2D and 3D model-based definition from CAD to part, from CAD to quality. All the rest going to be manual. In many cases, when you get supplier getting only model-based definition, there is a lot of what I call viewer printing on a hard copying, adding dimension manually, doing reverse engineering, investigating. This is not Industry 4.0. Another layer, plan for quality inspection and collaborate better inside and outside. Again, talking about automated ballooning on 3D MBD to bill of characteristic. So either you have 2D print or 3D model. I don't want anybody to do anything by hand and do interpretation on the quality requirement. And of course, enable the collaboration via triggered-based workflow. No more paper attachment to email in we are going digital is the right way to go. When you have a workflow, call it dynamic workflow, trigger-based workflow, when you collaborate between individual department and supplier, we are all almost like on the same system. Seamlessly collect and analyze inspection data in real time. Remember, we talk about real-time SPC. Real-time SPC required real-time data reading into your database, right? So when we say seamlessly collect and analyze inspection data, that means that at the beginning, we created the 2D and 3D bill of characteristic and assign all the quality requirement ahead of time, as I mentioned, including SPC. Now we need to read automatically inspection results from any inspection tool on the globe, automatically. Can be CMM, VMM, R machine, even manual gauges, wireless, whatever. For digital data, digital life, we would like to get real results, real time. Yes, FAI is one thing, but am I getting real data? And when we get real data results, I can see my CPK, PPK real time, so I can apply prevention, not just good part and bad part. So that's maybe another leg into it. And allow creation, sharing, approval of quality reports in real time. Now we're getting also into the documentation I mentioned earlier. Today, you cannot give your customer parts. Parts goes with data, with paper, with report, a lot. And we would like to have these reports or this document available. Me as an OEM, I need to share documents with my suppliers, but not hard copy. Documents are digital and I can access them real time on a platform that can make it happen. So with that case, I don't need to create reports. I can read directly results or upload directly results into my customer forms, either FAI, PPAP, or other data required to deliver together with the part. No more tons of people creating papers. So that's about the software that can help. Now we would like to get and say, okay, what does it mean, the software that can help? It should be one source of digital truth. No more paper, database driven. Buyer and suppliers with quality at the center. Now we can see here kind of an idea. What is the platform that we are talking? How buyer and supplier can collaborate seamlessly, digitally. So you can see here on the left side, the OEM and the buyer. You can see the platform, which can host AWS, Azure, private cloud, public cloud, whatever it is. And you see the supplier side. The whole idea behind supplier buyer collaboration is actually bringing your supplier to your shop floor despite of the distance or the language. So you can see on the left side, as a OEM, you can enable centralized document FAI PPAP, whatever 2D or 3D you're going to work, who can do it, who is my next job, results real time, get all my supplier on one system. And this is, by the way, not replacing ERP system. It should be clear. We are integrated with ERP system. And of course, you reduce overall cost, internal, direct and indirect, of course, and everything should be secured. As we mentioned, AWS.gov or private cloud, whatever the OEM buyer like to do utilizing this platform. On the other side, the benefit for the supplier, his investment in understanding the requirement dramatically reduced. You don't need to look into 2D print, bubble it, and think about the OEM today who outsource the same part to 3 different suppliers, give them 2D print naked, and then each one of them will bubble it separately. So now you get 3 different lots to your incoming inspection. I don't need to describe more the outcome of this, call it chaos. But again, on the supplier side, it's going to be like, I know how to make parts. Don't let me to do interpretation on your requirement. It should be clear. I don't need to guess anything. And that's the idea. You can get everything bubbled. You can get all the quality requirement. You can get the requirement for SPC. If you make the part and upload results, you can see them real time on your side, even before you upload results. But the idea is condense dramatically the misunderstanding, the disconnect, the interpretation between OEM and suppliers. So let's take a few minutes look how it really can work. Okay, so
HiQA is reimagining manufacturing quality. Our unified platform helps you win more business by simplifying and automating your manufacturing quality, both internally and throughout your supply chain. HQA 360 is an all-in-one manufacturing quality suite that optimizes your quality planning, inspecting, and reporting with intuitive tools that help your teams deliver high-quality parts on time, on quality, and on budget. Let's start with our dashboards. As a quality leader, you have a bird's eye view of all the projects you're working on. Personalized dashboards are available for each user based on their role in the team. For example, here, I can see that I'm responsible for reviewing 2 NCRs and 5 FAIs that are assigned to me. But let's start at the beginning with a brand new part. Whether starting with a 3D model or a 2D drawing, you plan your quality with intentionality. With one click, you can automatically balloon and extract quality requirements. Add depth and detail to inspection plans in minutes by assigning gauge categories, criticality, SPC target metrics, and even assign operation steps. With planning complete, inspectors simply scan a QR code to bring up their inspection plan and start recording their measurements. HQA 360 collects measurement data from any source, providing immediate feedback and SPC analytics to inspectors. With all your data in one secure and scalable database, generate any document you need to finalize your job, including FAI, PFMEA, Gauge R&R, SPC capability studies, and much more. Document templates are customizable and interactive, so users can complete them in a live environment. What's more, every document is managed through our dynamic workflows, so you know the status of any document at any time. Now, looking back at our dashboard, we can see that we were able to approve and finalize all 5 FAIs, which we were assigned to. We've cleared through our backlog in record time. With HQA 360 taking care of your internal manufacturing, let's see how you can better manage your supply chain quality as well. HQA Hub is a supplier quality management software. It leverages HQA 360 so you can share, collaborate, manage, and monitor data with suppliers and customers from an all-in-one manufacturing-driven database with quality processes at the center. Whether your suppliers already use HQA 360 or not, the experience is the same. Your quality requirements and part data are sent to them in real time, reducing interpretation. Suppliers can input measurements collected from any source, giving you visibility of production data as it occurs. They can complete submission documents so you can validate quality before parts ship. In this way, you are able to manage your suppliers collaboratively with full traceability and transparency. Let's look at an example. You as the buyer have just received 2 notifications. Let's check them out. We can directly open and review this incoming NCR from our supplier. In the NCR, we can see exactly which feature failed on the part. Once we're done, the workflow will notify the supplier of our disposition. Next, we can review the FAI that was submitted. Digitally sign the document and send the signed record back to the supplier. It's as if your suppliers are part of your shop floor. Both HQA 360 and HQA Hub are built on the most secure infrastructure available. Hosted in AWS GovCloud, your data is fully encrypted both at rest and in transit through our state-of-the-art end-to-end encryption protocols. Fully ITAR compliant, we also have built-in digital rights management, letting you manage which specific users in your network and among your suppliers can access specific content. Understanding that high QA products fit into a larger network of software solutions running your business, we have a strong RESTful API so you can integrate with any ERP, PLM, MES, or other systems you may have. High QA delivers enterprise-ready solutions with all the support and services you need to bring your teams to the next level. Our implementation specialists are passionate about quality and will partner with you to ensure the smooth onboarding of your internal teams and your suppliers. And the HQA Academy offers on-demand certification courses to ensure that you and your suppliers aren't just complying with your quality requirements, they're thriving with them. Thank you for spending the last few minutes with us. We hope to be able to partner with you in the future so we can continue to reimagine manufacturing quality together. To learn more about High QA's quality solutions, please visit our website or contact one of our quality experts to get started today.
All right. Kind of a quick summary on the event, the session we had today. We started to talk about the industry challenges, and they are challenges, and where the industry is going, trying to move from heavy paper to digital, with Industry 4.0 driving the whole industry to that. And we try to show the gaps where it resides. Industrial revolution not necessarily happening in one day. And we try to share with you that there is a tool or solution, if you will, that can support either you are OEM or you are a supplier to become a digital process in a heartbeat, if you will, and definitely collaborate between OEM and supply chain in a digital way and seamless collaboration. And with that, I think I would like to thank you for taking the time, and I think we're going to go into a Q&A, right?
Yeah, that is correct. Thank you very much. Before we go to the Q&A, I want to remind everyone that this webinar is being recorded and you'll receive a follow-up email with a link to the recording so you can revisit it whenever you like. And while we've already received some good questions, there's still time for you to submit one. Just type it into the question pane at the right side of your screen. And we'll do our best to get to it. One person asks, does this system provide the OEM with greater visibility into the supply chain, thereby revealing the multiple tiers that may exist but are not visible to the OEM?
I'm trying to read it. Does this system provide the OEM with greater visibility on their supply chain, thereby relieving the multiple tiers that may exist but are not visible to the OEM? It's an amazing question. And this is one of the biggest pain, I think, in the supply chain. I didn't want to get into it, but if you're going to whatever, car, airplane, and you take one part and you ask the OEM who made it, not necessarily they know, because they outsource a wing or a body into tier one, and then tier one propagate it down and down and down. So high QA, and I think Chris can explore more. I think it's a coming release plans to have multi-tier supply chain. So it means that if tier one wants to outsource it to tier two, then the OEM should know exactly, approve it, and then you have a complete traceability down to the suppliers to understand the source, or call it traceability, on the manufacturing process. Chris, you have anything to add into it? Are you on with us?
Yep. No, I'm here. Yeah, that's all accurate. That's something that is part of the hub experience. There is being able to see that traceability, both from a reporting and from a data analytics standpoint, just to see how orders were split out that way. Yep.
Okay.
All right. Next question. Does the supplier need to have high QA?
Chris, you would like to answer that?
Yeah. So no, that's part of our entire concept here, is that we understand that for an OEM who has tens of thousands of suppliers, potentially, they certainly wouldn't all be using high QA day one, maybe later. But so part of the hub platform is it is a data exchange platform that allows for the OEM to connect, obviously, with high QA customers who are their suppliers, but also it provides a cloud-based experience for any supplier, any supplier who doesn't already work with high QA products. And so we're basically providing that experience, all of the tools and everything through our cloud-based infrastructure, so that it works almost like a portal type experience for the supplier to log in, see any orders that were passed down to them from the OEM, and do all the work that's needed to fill in the data. But the supplier is still benefiting. It's not just like a document portal. They're able to use it, all the tools in our standard applications, to be able to collect data, even sync data from their CMMs directly, and so on. So all that's made available to the supplier basically for free, based on the environment that the OEM sets up for them.
All right. Next question. Is the solution available AWS as a public cloud or a private cloud?
Right now, it's AWS GovCloud, but there are. Actually, the question might be asking something slightly different. So I'll answer two ways that I think it might be asked. Is we are currently working in GovCloud because we have a lot of DoD type customers. We do anticipate potentially having a standard AWS cloud environment as well. That remains to be seen. But certainly, you can also host, quote unquote, on-prem as well. And that can be in any kind of server setup that you might have. So that can be on physical servers that you might have on premises, or it could be in any sort of like cloud infrastructure you might already be using. So AWS or Azure, or it could literally be anything, really. But our our kind of mass offering, our SaaS level offering, is hosted in AWS GovCloud.
Well, let me explore here. We have currently also customers, when we talk about private cloud, not necessarily in their local area network. I cannot mention DoD names or defense companies, but they are who are hosting it at Azure. And the idea is that you can install high QA environment on a private cloud, can be Azure or AWS, and DoD or defense customers that we have large and said, well, we would like to manage supply chain, but only us going to manage it, not through high QA. It's available. This is another unique approach by high QA because we understand the requirement. So for us, either it's Azure or AWS on a private, it's almost transparent.
Okay. And is the training available remotely?
Training, yes, is available remotely, but more than that, high QA established a year ago already what we call the High QA Academy. It's not just available remotely, it's available online, real time on the user pace, and it's divided into topics and user role, and even supplier training is available. If you are a customer who has X amount of suppliers, your supplier will have their dedicated vertical certification training to be able to serve you as an OEM, and that is already available in high QA. It can be also on site, and we do a lot of what we call implementation and integration that can be done remotely or on site, but it's all available through high QA professional services and integration team.
All right, that looks like all the questions answered, and time's nearly up anyways. So we hope you all found this valuable. Thanks to everyone for attending the presentation, and thanks to Sam for the informative talk and for fielding questions about the material. If you have any other questions or would like more information, you can reach out directly. And again, I remind you that you will receive an email with a link to a video of the presentation. Thank you all for joining us, and enjoy the rest of your day.
Thank you.